Okay, sound testing, Yes, there is sound. Good. Okay, good afternoon, everybody. How are you guys doing? Hi. Hey, Sujai, how you doing? Huh. Okay, let me check out a couple things. What is this? Okay. All right. So, welcome back. Let me. You guys have this. You've seen this mug, right? Okay. So, hey Albert, Reinaldo, Abel, Juarez, how are you guys doing? Okay. So, having problems again with the viewer count on YouTube. I can't really tell how many people are connected right now or who is out there if you don't say hi. Um, anyway, hi, good afternoon. How's everybody doing? Um, if you, hey Rafael, how you doing? So if you are coming from this morning's stream, you know that what we're going to be doing this afternoon is that we're going to continue recording these videos that I'm putting together for a course or a series or a playlist or however you want to call it on Introduction to Parametric Modeling. So I'm basically going to be reviewing, teaching you how to use vanilla Grasshopper from scratch, and I'm going to use this as a way of going over a lot of topics that I think are interesting and important in the world of parametric modeling, such as geometry operations, such as the logic of processing geometry, etc., etc. And if you're new, and if you just landed here and it's the first time here, hi, my name is Jose Luis. I teach architectural technology at the Harvard Graduate School of Design, and I also created this thing called Parametric Camp, which is right now is basically a YouTube channel where I do live streams on computational design, and I record videos and tutorials on things such as parametric modeling, geometry jams, and all those kind of things. But I want to build it into I want to build it more into a community in the future, where maybe we start organizing events, maybe we start like having other people come and teach videos and teach things that they know how to do. So I'm going to invite you, if you're here, if you're new, I'm going to invite you to subscribe, so that you can be up to date with what we publish. And if you hit on notifications, then you will get emails and pop-ups on your phone whenever we go live and whenever we post new content. And also, I'm going to invite everybody who just joined to join our Discord. If you wish to do so, we are going to be doing here. This is the Discord. We have a server where we introduce each other, we talk a little bit, we have a bonfire because it's parametric camp, so we have a bonfire channel where we talk, we tell our stories, we share our work, and this is helping me a lot. Actually, get to know who you guys are, where you're coming from, what your interests are. So I'm actually very happy to do that. Andres, what is it that you do not see how to enroll? What is it that you probably already subscribed to the channel, right? Anyway, if you're not subscribed, I'm going to post, this is where you should go to subscribe. But actually, sorry. No. Yes, that's the right place to go. And for example, and the Discord is helping me, for example, get to know people like Reinaldo, like Rafael, like Andres, people I keep seeing over and over coming here and sharing their thoughts on the chat. Okay, so no, I mean about the artificial intelligence workshop. Which artificial intelligence workshop? The one that I'm teaching at Digital Futures? Is that the one you mean? Also, Rafael, yes, thank you for the reminder. And today we're going to be recording more videos for the intro to parametric modeling, but we will have social and Q&A by the end of the stream. So it's probably going to take me like about a couple hours to record more videos, and so we'll probably do like a bit of Q&A and social at around 4 p.m. my time, Boston time. And there we'll talk about that, about computational and about terminology by the end of the okay. Andres, if you want to talk about if I think what you mean is Andres Obregón, if what you mean is you want to talk about the detailed futures workshop, I will probably talk about that by the end of the stream. Yeah. Okay, so where were we? Let me see my notes. Hopefully it's going to be a little less bumpy this afternoon because now we got a little bit of warm up from this morning. Okay. Okay. All right, so I think we're ready. We did installing Rhino, basic Rhino. We did a piece on what is parametric modeling, and I did this example this morning with the cylinder. Can you guys see my screen? Yes. We did this example this morning with the cylinder. So I think we're ready now to do like a video on okay, so Grasshopper, the interface, and how does that look like? How can we and then I'm going to customize it for the way that I like, so like icons and that kind of stuff. Even though I will be using bifocals throughout these, I will be using bifocals so that people who watch these tutorials and do icons, so that they can so that they can at least get the, I'm going to be doing bifocals. Okay, any questions before we start? Himanshu Raj Puyohit. I don't think I've seen you before. Hi, welcome. How are you doing? Feel free to join the Discord and introduce yourself. The link is somewhere back in the chat. Yeah, so I think we're ready to go. Okay, so let's talk Grasshopper. Let's talk about the interface. Maybe I want to save this file so that we can. Maybe I want to save it so that we have like a basics. Yes. So basics. I'm gonna just basic cylinder, so that it's part of the course files. Yeah. Okay. Okay. So let me breathe into and focus, so that it doesn't happen like this morning that I'm all over the place. And then there you go. And here, okay. And I think let me organize a little bit of my windows here. Okay. Have you guys seen this mug before? Look. It's got a smiley face. I've shown this one before. This guy always with his old same jokes. Okay. What are we doing now? Yes, so we are going to. Okay, so I'm going to stop this here, and I'm going to close this one. Okay, and here we have this that I'm going to dock properly here, and we should be good to go, right? Okay, So I'm going to explain first so I'm going to first explain the interface, and I'm going to explain, well, we already know how to dock these things next to each other, the basic menus. So I'm going to explain like you have like menus and options and blah, blah, blah. And then I'm going to explain the components menu. So I have tabs, and you can expand this, and you can drop components. And then I probably want to say that I have a ton of plugins, but that's fine if you don't have them. I'm going to drop a component, and I'm going to drop a component. I'm going to drop what? I'm going to drop construct point, and I'm going to apply some sliders. And then I will explain that the relationship between Grasshopper and I will explain that later. And I also want to customize this. I want to show you what are the options that I like for working with Grasshopper. Because again, since I'm recording these tutorials, I think I get to choose what I like. But of course, everybody gets to choose what they like on their own. Anyway, I'm ranting again. So let's get to it. And we did the cylinder. We're coming from the video that I explained the cylinder, so I should start by saying, okay, let's just take a closer look at the interface, and then I explain the canvas. Yeah. Okay. Let's take then a closer look at the Grasshopper interface. The Grasshopper. Did I say the Grasshopper? Grasshopper. Okay. Now that we're a little bit familiar with Now that we are a little more familiar with what parametric modeling is and the relationship between Rhino and Grasshopper, let's take a closer look at the Grasshopper interface, and let's break down everything that we can see around. And let me show you how the basics of creating a small Grasshopper definition works. And then I will also want to show you like how to customize Grasshopper in a way that I think makes life easier and better, and then it's going to help you learn this process faster. Okay, so the first thing that I would like to show you is that, again, Grasshopper is this floating window that we usually dock side by side next to Rhino, like I showed in my previous video. And then we can see several things. So first of all, we do have here a top menu with a lot of the usual suspects. So for example, opening a new document, saving the document, and like accessing some special folders, etc. Copy pasting stuff, finding stuff on definition, and then a bunch of other menus that are a bit more specific to Grasshopper, the things that happen in the world of Grasshopper. So I will explain at some of these options in a second, but then I want to point you to the second most important part here in Grasshopper, which is what I believe it's called the component ribbon. And the component ribbon is basically this area where we have a lot of tabs, and each one of these tabs represents families of components. Components being each one of these boxes that represent an operation that we can perform in Grasshopper. Okay, a parametric modeling operation, a geometry generation operation, or all other kinds. Okay, they are distributed by categories. So you have like primitives, mathematics, sets, vectors, curves, And if you want to learn what they're actually named, you just have to hover over them, and then this pop-up shows up with the full name surface, for example, and all the components that are inside. And inside of each one of these, you can find that there are certain categories. So for example, inside of vector, we can find grids, we can also find planes, we can find points, and we can find vectors, right? And all these drop-downs, each one of these icons represents one of these components that we can use for geometry manipulation or generation. So for example, if I go to vector and I go to point, you can see here that the first one that shows up is construct point. And if I hover over it, I get a tooltip description, construct a point from XYZ coordinates. So if I click and I drag this all the way down here on the canvas, you can see that this box pops up. And if I hover over this box, I get the tooltip saying this is going to construct a point from XYZ coordinates. All right. For example, let's take a closer look. So this area here, the one that I have, the one that I can move around and drag is called the canvas. And this is where I deploy, this is where I drop all my components and where I link them with wires, and where I can create this parametric definition of the geometry or the model that I want to generate. Okay, things that I can do in this canvas is with the right button I can pan around. Okay, with the mouse wheel I can zoom in and out, and then if I click on the component with the left mouse I can move the component around, and if I click on the component with the right button I can get some of the options, which I will get to in a second. Okay, this you can zoom in infinitely, you can zoom in out. So this is the main area where we're going to be working and assembling our parametric logic. Okay, so as I showed in the previous video, I believe, we're going to create a very simple definition where we're just going to create one point that is parametrically controlled. So you can see that I dropped here this component that constructs a point, and I will explain a bit more of this in a second. And you can see, if you go to primitives and to inputs, you can see that here we have this component that is called a number slider. If I drop this number slider here and I copy paste it 3 times, I just did Ctrl+C, Ctrl+V, you can see that now I have 3 values that are controlling the location of my point. And then if I move the X coordinate, the Y coordinate, and the Z coordinate, we can see that the pre-visualization of this component here is showing us where that point is in 3D space. I can also go to primitives, inputs, and panels, and I can drop here a panel, which is basically a text box that if I connect to the output of the component, I can see the coordinate representation of where this point is. And you can see that, as expected, the X coordinate matches with the X coordinate, the Y coordinate, the Y coordinate, and the Z coordinate with the Z coordinate, right? If I take a closer look at the component, it is very important to understand that components always, at least 98% of the times, components always have inputs and they have outputs, and they work from a left to right way, which means that everything, all these knobs that we can see on the left hand side, each one of them are inputs, and if we hover over the input, we can see a lot of really important things. So we can see, for instance, we can see a description that says that this needs the X coordinate of the vector. So here I can feed in the X coordinate of this point. And another very important thing is that I can't really point to with my icon, but you can see that the yellow tooltip on the top left corner has an icon, the hexagon icon with the black background, that has this 0.1. That 0.1 is telling us that the type of data that that input needs is a number, okay? As opposed to, what you can plug in there is anything that is giving you a number, but you will not be able to plug there things that give you, for example, curves or points or other things that are not numerical, right? If I hover over the Y, you can see that same. I request here a Y coordinate, and it also has to be a number with decimal part, and the same for the Z. This is very important because very often what will happen is that components require specific types of data and they can only work with that type of data. So for example, if I want to loft a surface over a bunch of curves, I will need curves as inputs. I will not be able to loft a surface over a list of points, right? Same thing here, I cannot plug in a curve into the X component because the component doesn't know what to do with a curve when it expects a number, right? So this will be a very common mistake that we will do at the beginning. So it's very important as we start getting to know components that we analyze by hovering over them, that we take a look at that black hexagon to tell us what type of data is either requested as an input, or if we hover over the output, you can see that the output is telling us that it's named point and is giving us a point, and that hexagon has the white cross that is representing that the type of data that is coming out from the output of this component is of the type a point. It's not a curve, it's not a line, it's just a simple point. But you may ask me, well, but Jose, how can I know that that X in the hexagon represents a point? Or how can I know what that icon actually means? Well, it's actually fairly easy. If you go to parameters, and if you go to here to geometry or to primitive, you can see that all these components here have these hexagonal icons, and they have a description here: Boolean, number, integer, text, or for example here, the one with the white cross, this one is a point, right? So as we start getting to know Grasshopper, at the beginning it will be useful to go here and take a look at those icons and what those icons represent in terms of data types, okay? But we will see more of that later in a second. But this is the basics of creating a Grasshopper definition. You can also double click on the canvas and start typing construct point, and you can see that a list of suggestions pops up. So I can click on this one, construct point, and then I can take the output of the slider, which is a number, and plug it into the input of the point. I can take the output of this other slider, plug it into the input Y, and take this output and plug it into the input Z. And therefore, linking those sliders that allowed me to output a numerical value to the input of this component. And the same for the panel. I can link the output of this point to the input here in the panel to get a numerical representation of this point, okay? So this is like the super basic introduction to how components and work, what type of components are, what type of data we can work with, and how to link them together with wires to create this chain of reactions, okay? But let me show you first a couple tricks of how I would like us to customize our Grasshopper UI so that we can all work together with the same set of parameters, okay? Let me show you that. Okay, I think I actually want to make this a separate video. Yeah, so that's going to be yes. All right, how are we doing there in the chat? Is the sound in the video? I saw the video was a little choppy before. Is it still choppy? Okay. All right. Well, it's really hot in here. Oh, I shouldn't be doing that with the mic. Okay. All right. Things I want to customize is going to be no turn the profiler on. Okay. No, shit, no. No compass. Okay. Bifocals. Okay. All right. Okay, before we move on, let me show you a couple of things that I would like to customize in the Grasshopper UI, because I believe are things that are going to make our life easier, faster to work with Grasshopper, and better to learn. It has been my experience as an educator, I've been teaching Grasshopper for many, many years already, that these features or these things that I'm going to change, I believe are going to help you remember and learn a lot of things in Grasshopper much, much faster. Okay, the first thing that I would like to do, and this one is, I know it's a controversial one and a lot of people have different opinions about this one, but the first thing that I would like you to notice is that this component here, the construct point, is when you go here to the vector tab here, there's this icon here, and also when I hover, and the hover part, there's also an icon that is a description of this component. However, this here, instead, we have a text representation of that component. The world of Grasshopper is divided between people who like text or in their components, or people like me who like to actually see this icon here on top of the component, which is an option that you can turn on if you go to display here, and if you click on draw icons, then you will make all the components change, and then the component will display this icon as instead of the text representation. By default, if you use Grasshopper as it comes out of the box, you do have text enabled. But it has been my experience that if you are using a visual programming language, you're probably a visual thinker and somebody who has a really good memory for images. So I believe that it's easier to remember components, and it's easier to read definitions, to read other people's scripts if you see icons instead of seeing like a lot of text. So if you've never used Grasshopper before, I very, very strongly recommend you that you turn on display and draw icons for two reasons. I think it's going to be best for you, and also if you're going to follow these tutorials, this course, I'm going to be using icons all the time, so it's going to make your life a little bit easier. Nevertheless, because I know the world is divided, there is this wonderful plugin that you don't have if you have just installed Grasshopper in your life, but there's a plugin called Bifocals that what it does is it just adds this small tooltip description of the component on top of it. It's like an automatic thing. So this, I think, is a really, really great tool for people who are teaching like me, and who want to cater to both worlds, people who are text component people and people who are icons people. So I'm going to hopefully consistently be using icons throughout this course, but I will hopefully be using bifocals so that you have an additional description of what this component does. It's also, this text is the one that you should input if you double click and you want to find construct point. This is the text that you should input. So if you're watching these tutorials, you should, if you don't know exactly where this icon is or how to find it, just go ahead and double click here and type construct point, and then you will find that. Additionally, there's also this option that will help you find components. So if you have a component and you don't know where this component lives, you can click Control Alt and you can see how this information icon shows up. And as you click the component, Grasshopper gives you these arrows that tell you where this component lives. So if you're using somebody else's definition and you don't know where that component belongs to, you can find exactly in a very fast way where this component lives. Okay, so this is my main big one. I very strongly recommend you do draw icons, but it's something that you have to explicitly turn on. All right. Another thing that I also like is, for the exact same reason, you see that these tabs here are all text descriptions of these categories. And also, if you just installed Rhino, you probably don't have any beyond this one, beyond display. You don't have any other tabs. These are all plugins that I have installed over the time, right? So for the same reasons, I like these ones, instead of being text, I like them to be icons. So you can right click on the tab and just press display as icons, and therefore you can now see these icons representing the tabs, and you can see some of the plugins also have their own icons, but also it takes much less space. It's much easier to see, at least in my opinion. Another thing that I would like to recommend you is, by default, this ribbon only has 2 rows. I kind of like it a little better when it's 3 rows because it doesn't take much more space, but it gets me to see everything that I have accessible as part of my component toolbox. So I like to expand it one more level. I like having 3 rows. So you can do that here by dragging this up and down, your choice, okay? And then another thing that I would like to recommend you is that by default, Grasshopper comes with this option called obscure components that is disabled. What this means is that Grasshopper, for example, here in the vector, in the curves tab, if I go to curves, I can see that here I can only see the pre-visualization of 10 components, but if I drop down, I see that inside of analysis, there's actually many more components. I think this was a decision by the Grasshopper creator to just hide the components that are not very common, or that you only would use like once every so often, to just give you a clean view of the ones that are more popular or more used across the. I think the intentions behind that idea were good, but I also think that having a lot of icons here, and seeing them and being curious about like, oh, what is this icon representing? What is this curve proximity? What is this curve side, blah, blah, blah. I think it's a really good exercise for learning. So I actually do like to see the full palette of all the components showing up there. So I'm going to invite you, especially because you're learning, I'm going to invite you to turn on obscure components so that now we have the full length of like all the components that are available. And again, I think this works pretty well, especially if you are working with icons turned on or your components, because then you can see the link between the components and the tabs. But this is a personal choice. You get to choose. Maybe this is a little too overwhelming at the beginning, but I strongly recommend that you do, so that you have like full exposure to everything that is available on your toolbox. Another thing that is going to be optional for you is going to be that components, their inputs and their outputs, are a very short description, like usually 1 letter. But that doesn't have to be like that. So if you go to display and you click here on draw full names, you can actually get components, and you can get panels, and you can get sliders to have like a full length name of what these inputs and these outputs are. This might be good at the beginning, but I think the single letter descriptions are fine. I've never found this a problem. So I'm going to leave this up to you, but I will have it disconnected. I will have it off during the course of this course. Okay, it's a choice, and I think that anyway, if you hover over them, you can still read the same information or even better. So I'm gonna leave that up to you, but I will have it disabled during this course. And then a couple other things that perhaps might be useful or not. You see this thing here? This thing is called the compass. And it's supposed to be this kind of arrow that is telling you where the components that you have selected and where the rest of the components are. I'm not sure how this is very helpful. I think this has been there since the early times of Grasshopper, but I've never really found use for it, and I believe it actually takes up some resources. So if when you're working with heavy definitions with a lot of components, it's actually taking a lot of resources. So I don't like having it in, and I find it distracting. So I'm going to invite you to go to Display, Canvas Widgets, and here in Compass, just to deactivate it, to turn it off. Okay. That's how I'm going to work with my own Grasshopper. And finally, something that I do find useful sometimes, especially when I'm working with big definitions, is that to turn on this thing called the profiler. So in the same section that we were before, Display, Canvas Widgets, Profiler, if you turn this on, the profiler is a component that shows you how many milliseconds each component is taking up to execute. Here, because this went really fast and it's super simple, it took nothing. But if we use a heavier component, such as, for example, I don't know, let me drop a grid. No, this doesn't work. Let me drop a grid. You see, here, this component took 15 milliseconds to execute, which is nothing. It's almost nothing. But this widget here, this is coming from the profiler, so I can turn it on and off. Okay, this sometimes helps identify whether if a definition has like some bottlenecks, or if some components are just taking too much, and where things could perhaps be optimized. So I think it's a good thing to have. So I'm gonna keep it on also for the rest of these of this series. Okay, and I think with that, I think these are all the suggestions that I have on how to customize the UI. Okay. All right. Okay. All right. Bifocals are here. Okay. So let's start. I think it's probably time to. I think it's probably time to. Oh, I did this already. All right, I think it's time to go to a new section that I'm going to call basic operations. So we're going to do a little bit of arithmetic. We're going to do a little bit of arithmetic, and we're going to break down the architecture of a Grasshopper component. I kind of did that already. Huh. That's not great, but yeah. Mm-hmm. Basic arithmetic. Okay. I'm actually wait. Let me bring this back. Yeah, because I think I'm going to talk about this. Huh. Okay. Okay, so explain again. Let me do the cylinder one here. Okay. Okay. do I want to start with this right away, or do I want to build this? I probably want to, I can probably just say like, I can probably just say that it comes from what we did in the previous video. Yeah. And what I want to do is I want to take a closer look at components and their inputs and their outputs. And I encourage people to explore. Actually, so let's just build this. Let's just build this manually. Yeah, let's drop the cylinder component and let's explore that through the options. Yeah. Wait, I'm still thinking. I'm still thinking how to do this. Share component. Okay. All right, before we start delving deeper into geometry problems or looking at making larger Grasshopper definitions, I would like to take a closer look at the architecture of a Grasshopper component, because it will be something that will be very important for us to understand how it works, but also for you in the future when you're not watching these tutorials to try to learn and try to understand how new components that you may find down the road, how to learn how they work and how to learn how to use them. So as we said before, components have three main parts. They have the left-hand side, which are the inputs. They have the middle part, which gives us, so they have the left part, which are the inputs, and over the inputs, we can hover with the mouse, and then we get this tooltip that is telling us the name of the input, what it's requiring, and it's showing us the hexagonal icon that is telling us what type of input it's requiring. So for example, as we said before, this has this icon that says 0.1, and if we go here to primitives, we can see that this corresponds to a number with decimal part. The same for Y and the same for Z, right? If we have to remember that we can right click on top of these inputs so that we can access some options inside of those inputs. So for example, we can choose how the wire that comes into this input looks like. So by default, we have a thick black wire, but this can be very thin, or we can use a hidden that I don't really like doing this because I like seeing where those wires come from. But if you ever click the component, this will show up solid. So if your definition is very messy, I recommend that you do faint, and that you only use hidden for in really bad scenarios. Okay, I don't think that's a really good practice. Other options that are available here is that you can disconnect this cable by going to here and disconnecting this input, the slider. So you can now detach, and I can reconnect this again, for example. There are a bunch of other inputs that are coming here, reverse, flattening, blah, blah, blah. We will see what these do farther down the road, as well as what these ones do. This is not very helpful right now. And you can also access this small help that gives you a breakdown of what this component needs as an input. In this case, it's telling us that it needs a double parameter, and double is a computer science term for a number with decimal part that has a lot of precision. It's just that it, okay? So double precision floating point values, like you can see here. Same goes for the center of the component. At the center, if we hover, we will get the name of the component. And this will be the name that we can use to double click on the canvas and bring it up. So construct point, for example, you can see I can access that through here. And then as I right click here, I can see some options that are available to me. So for example, you can see that this component right now has a preview on the viewport, right? So if I move this around, you can see that we have a preview of this point here on the viewport, and I will explain later what the relationship between previews and geometry is, but for the time being, we can see that this point is showing here. And we can see that when I click this component, this preview turns green. This is very useful when we have a definition that has a lot of components. We can click on each one of the components and see which geometry on the Rhino viewport corresponds to that geometry that we just clicked, to that component that we just clicked. But if our definition grows very large, we can actually choose to turn off certain. So for example, we can choose to disable the preview. So now it's still working. It's still doing its thing. It's just not showing up on Rhino. And we can turn the preview on again. The same for enable. We can choose to just completely disable. So now it's not showing and it's also not working. It's like turn off. So we can turn it on again like this. And then last but not least, we can see that on the right hand side of the component, we have the output. The output is telling us what the component is giving us, so a point through its coordinates. And the icon is also telling us what type of data that is. Remember that white cross, if we go to geometry, we can see that it is a point. Okay. This kind of looking at a component, reading the inputs, reading what the component does. So for example, something that is very important as well is we can right click on the center, click on help, and then we get a pop-up with description of the component. This constructs a point given some X, Y, Z components, which have to be a number, and the output is a point. Okay, so this is a very simple component, but it's a way of reading a help text that describes what the component does. And then the output, also being very careful about understanding what types of data this component is outputting, because as you will probably see very soon, the types of data that a component matches, that a component outputs, needs to match the input where you wire that cable into the next component. Okay, let's take a look at that. Let's take a look at that in a second. But this idea of reading through the inputs, the description of the component, and the outputs, and understanding what the component does and what data it needs to work with and what type of data it gives as an output is very important, because it's a technique that you will need to use to understand any component that you may want to explore. Because in this course, we're not going to go over all the components, and I'm actually going to invite you, the viewer, to experiment on your own, to just go ahead and be like, oh, let me just go to curves and figure out what kind of components are there. Circle 3 points. What does this do? Well, it creates a circle defined by 3 points. So what are the inputs going to be? It's probably going to be A is going to be 1 point, B is going to be another point, and C is going to be another point. And you see that the 3 icons are giving us that. And then the output is going to be C. It's going to be the resultant circle. And I can see that this icon has like a ring on it. So if I go here to geometry, I can see that this ring looks like a circle. So P, what is it going to be? The plane in which this component is, in which this circle is contained. And I know that that is a plane because if I go here to primitives, that icon looks like this one here, the plane. And R is going to be the circle radius, because since we are giving it 3 points, we don't really know the radius of that circle. So it's output here in the form of a number. Okay, so now all of a sudden I know how to use this component, and I know that if I build, for example, this and another one, and I gave this like some random values here to the 3 points, etc. Right? Now I have 3 points, and I know I have 3 points in space. And then if I connect each one of these 3 points to A, B, and C, I'm going to get one circle in 3-dimensional space that is going through all these 3 points. And if I connect panels to C, that one is going to be, this is the circle, and then second is going to be, this is the plane that is containing that circle, and then third is going to be this radius, the radius of the circle that I just generated. Okay, so that made things very easy for me to understand. So I very, very strongly recommend that without fear, you're not going to break anything. Grasshopper is not going to crash. Without any fear, you just go ahead and start exploring. So go to surfaces and go to primitives and see what kind of primitives can you do. Oh, I can do cones, I can do cylinders, I can do spheres. Oh, but I can do 3 types of spheres. I can do sphere based on a base plane and a radius. I can also do sphere based on 4 points, and you can see that the icon is slightly different. So this is going to be very similar to what we just did with the circle, but just with an additional point. So for example, this one here, for instance, I don't know, and I'm going to plug this here, 0.2, 0.3, and 0.4, and boom, I have a sphere that is going through those 3 points there, and the output is the center of the sphere, the radius of the sphere, and the surface. This icon here is the same as this one, surface. So you can see that the output is a surface in the form of this sphere. Okay. So go to curves, go to vector and explore planes, explore points, explore vectors. Go to curves and see in primitives how many types of different curves can you generate, how many types of splines can you generate. Go to surface and go to freeform and see that you can do extrusions, you can do pipes, you can do revolutions. Where are revolutions? Revolution here, ray revolution, normal revolution, boundary surfaces. You can do a lot of stuff, and just by carefully reading through the component what type of inputs and what type of outputs it's giving you, then you will get a very, very good sense of what possibilities in terms of geometry manipulation Grasshopper is giving you, and then you will start learning, you will start building up a mental toolbox about what operations can you do. Okay, so remember, always read the description of the component, what it does, read the inputs, what type and what kind of data that component needs to work, and what is it giving you as an output. What type of output is giving you and what type of data is coming from it. Okay? Very, very important to learn Grasshopper on your own. Okay. Well, that one I improvised, but it actually came out nice. Let me save this. This is going to be what? Circles and spheres, for example. And I'm going to shut it. Okay. I'm going to continue with this one, I think. Oh, because I want to do input parameters. Yes. So I'm going to go back in time here. I'm going to go back to this one. Well, what is the bifocals? Okay. Okay, and then input parameters. Well, Awesome. Ah, yeah. Okay, I blanked. Let me start over again. We have just discussed the architecture of regular Grasshopper components, the ones that take data as an input, they crunch some operation inside of it, and they spit out some data as an output. That is the most common way of Grasshopper working, Grasshopper components working. And because these components represent a function, represent an operation, right? However, there is a handful of components that do not follow exactly that paradigm, that are not exactly boxes or operations that data flows through in and out. It's more components that help us work with the information and generate parameters and analyze those parameters that we will feed into other components. Most of those components are living here on the first tab, on the one that says parameters, and most of these are either work as pure inputs or they work as pure outputs, but they're essentially tools to help us navigate and operate with the rest of the normal Grasshopper components, the ones that take input, they crunch some data, and then they export some output. And these two components that I went on over very fast, the sliders and the panels, they fall into that category. They fall into the category of parameter components. So what I'm going to do is I'm going to delete them and I'm going to explain them over a little bit better. Sliders, for example, here, if you go to parameters, inputs, number slider, if you drop this component here, a slider is a component that has a specific UI that lets you drag this knob around the range of the slider, and therefore the output, so this knob here, the output of this component will be whichever number you are selecting with the UI. So for example, if I drop a panel here and I connect this slider to the panel, you can see that to the panel, I'm just giving it directly this number that I am controlling with my slider, okay? But what's interesting is that sliders, of course, are very heavily customizable. By default, when you drag a slider, the slider has a range from 0 to 1 with 3 decimals. But very often, we will want to customize that. So for example, here for this construct point, if we just, what we had before was these 3 sliders from 0 to 1. So that basically would let us build a point that is reduced to the 1, 1, 1 dimension space in 3D space, right? And we probably want to have the point have a larger area that it could live in, right? So what I'm going to do is I'm going to right click on top of the slider, and then there's a couple things that I can do. So for example, here there is a text box that allows me to write in my custom name for the value of this slider. So I'm going to call this, for example, x coordinate, and I'm going to hit enter. So now this slider is going to be always called x coordinate, and this is a very, very good practice, especially when you start having more complex Grasshopper definitions. It's a very good practice to keep things tidy, and we're going to talk a lot about that in this course. And another thing that I can do is I can right click here, and then I can say, well, let me customize exactly the range and the parameters that this slider is providing to the user. So for example, here you can see that in this screen, I can also change the name again. But something that I can do is I can say for the minimum value, I'm going to choose a larger, for the maximum value, I'm going to choose a larger value. So for example, 10, all right? And if I do that and I press enter, you can see that my slider now goes from 0 all the way to 10. All right, that makes a lot of sense. However, I want even more freedom, more range. So why not work with the minimum? The minimum, we can make it lower. We can even make it, for example, -10. I want my point to be able to be in the positive quadrant or in the negative quadrant. So now the range of my component is 20 units, from -10 to +10. I can also choose how many decimal digits this component may give me. So if it's a real number, a floating point, then I can choose the number of decimals, or I could choose, for example, to make it a natural number, or in other words, an integer, a number with no decimal part. I can even go farther and say, for some reason, I may want this slider to only give me even numbers. So for example, here from 10, 8, 6, 4, 2, 0, blah, 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 or to give me just odd numbers. So even the range is now changing because of that. So I'm going to go back to -10 and +10, and perhaps like a little bit of less decimal precision. So I think we're going to be fine with 2 decimal values. And now here, I have my slider that I can customize from -10 to +10. And I'm going to plug this in here. I'm going to copy it, paste it 3 times, Control-C, Control-V. And then, because I want to be like really, really tidy, I'm going to make sure that I update the names. So Z, Y, and Z coordinate. And as I zoom out, you can see that my point has a much larger range of movement now that I have controlled my sliders. Okay? So sliders are super, super important. They're the bread and butter of working with Grasshopper, and they're the easiest way to set a parameter, a value, a numerical value that we want to have as something that can vary, something that we want to play with, something that is going to be one of those, is going to represent the flexibility in one dimension that we want for some parameter of the geometry that we're going to generate with our parametric modeling system. Okay? The other parameter component that I want to talk about is the panel. Okay? The panel is also here in parameters, input, and panel. Okay? So you can drop it here. And by default, if you haven't done any, if you just installed Rhino and Grasshopper, this will probably show up yellow for you. I'm going to show you how to customize the color. But panels, you can think of them as empty text boxes. Okay? The only thing that they do is that they can either read text, they can either output text, or they can have text flow through them. And basically their main purpose is either for visual feedback, so that we can know what is going on through one of these wires with data. And then, and sometimes in reduced cases, we can use them as to output some data, because you see that they have 2 knobs. They have an input and an output. So what you can do is, for example, if I don't really know where this point is, or I lost track, or blah, 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 what I can do is just to verify what is coming out of this component, I can just plug this in here and see, oh, this is a point with these 3 coordinates. Okay, that looks good to me. And panels work in both ways. So right now I plug this in here. This is the input, so this is why we see this panel displaying this information. But it's also outputting through here the exact same information that is going in from the input. Panels do not have the capacity to change or to operate with the information as far as I know. So if you plug this in here, we can see that whatever came in is also coming out same from the other end. So I could do this like infinitely and plug like a bunch of them. This is very useless. I don't know why would you want to do that, but just for the sake of understanding how this works. Now, I will show you as well very soon, farther down the road, how we can use panels also to output some information and to use them as parameters. But I will get to that farther down the road. Okay, so these are the 2 most important parameter components that we're going to be using. Sliders to represent numerical information that can change and that we want to be able to control and play with, and panels as a way of having visual feedback on what is going on, what kind of data is going on through one of these wires that we use to connect components between each other. Okay? All right. Hola Ernesto, ¿cómo andas? Oh, I forgot to show. I forgot changing the color. Oh, and I almost forgot, customizing the color of panels. Super, super easy. You can right click on the panel, and then you can see that here where it says color, you can choose with this picker, you can choose like the HSV range. So I could choose purple, and I can also choose the opacity of the of the component. I'm not sure that you want anything like this, but if you want to change from yellow to white, for example, I think I'm a little bit of a minimalist, so I like simple colors. So you can just go all the way to HSV, and I like a little bit of transparency. So I like, for example, 200. I like to see a little bit of transparency through the panel. I think this is easier to read for my taste. If you want to make this the default, that all the rest of the components are, all the rest of the panels are going, the default color that all the rest of the default color that all the rest of the panels will always have, make sure that you right click here and that you set that this color should be the default for the rest of the panels. Okay, wonderful. So this is going to be really helpful, and with this I think we can probably start doing some basic arithmetic. Prajesh, can we put mathematical functions as well in panels? I don't think so. But I'm going to show you, like right now, how to do basic arithmetic, like mathematical functions with components. Okay. All right. Let me write some notes here. Let me write a few notes. Where am I? Okay. Remember. Okay. Is that what you asked, Prajesh? If you can do mathematical functions here inside of a panel? Let me change this color to full opacity. In fact, yes. Okay, so what are we going to do now? Okay, so we're going to start with basic arithmetic. Basic arithmetic. Okay, so for this one, I think I can probably go full screen, because we're not going to see anything on the screen anyway. Yes, and I can delete this and math panel and Tuva. Okay. Okay, so I'm going to end a slider. Oh, not this one. A slider that is going to go from oh, like the ones we had before. Okay. Value of b. So this is going to be 5, and this is going to be, oh, okay. Okay, 2, and this is going to be 3, and this is going to be 2. Okay. I think we're ready now to start doing some basic arithmetic with Grasshopper. So I have a couple things that I have done. So first of all, I have gone full screen with Grasshopper. So before I was docked here on one side, but since we're going to start doing arithmetic, we're going to do mathematics. We don't really need to see any geometry on the Rhino viewport, so we can maximize the Grasshopper canvas for the time being and have a little bit more of real estate for us to work. And what I have done as well is I have dropped here two sliders that range, as you can see here, they range from -10 to +10. And I have customized the numbers, sorry, their names to be value A and value B, just for the sake of keeping things tidy. So I would like to do some algebra operations with these two numbers, some arithmetic. So what I would like to do is I would like to probably want to do like, what is the most simple arithmetic operation that I can think of? It's probably going to be adding two numbers together, right? So the logic is, if this is an arithmetic operation, it's probably going to involve some math. And in Grasshopper, we have this tab here, the second one, that is called Maths, which basically has all the components that relate to doing any kind of like mathematical operation. So it will be very simple. Now, just from looking at the components, I can very clearly see that this one here, the addition component, is probably what I'm looking for. But if I drop this down, I can see that in operators, I have a lot of other components. So I have addition, multiplication, power, division, blah, 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 and subtraction. So this is probably where I want to be. I'm going to drag and drop an addition component here. I'm going to see that the input is the first item, the second is the second item that I want to add, and R is going to be the result of the addition. And you can see that the type of data that they take, this icon, is not going to be exactly the 0.1, it's not going to be the number as I expected the other day, as I explained before. It's not going to be just that. It's going to be this other one, more general placeholder that is called data, just because, as we will explain down the road, this component has the capacity not just to add numbers together, but it can also add together other entities that allow for addition. So for example, it can add together two vectors, or it can add together 2 points. You can actually add points together. So because it doesn't want to be very prescriptive about only one type of data, it uses this icon that represents generic data, stuff that I may or may not be able to work with. Okay, so adding this, and just for the sake of looking at the result, I'm going to plot a panel here, and we can see that the panel right now is empty because there's no data flowing into the component. So I'm going to connect this together. I'm going to connect the output of the slider here, and then I'm going to connect the other slider together here. And as you can see, this box is taking the two inputs and is adding them together. So the result is going to be the value of 5 that is coming out of this component. And you can see that, of course, if I change any of the inputs, then the result updates automatically based on that operation. Okay? All right. Yes, Prayesh. It cannot crunch, it just represents text. It cannot calculate anything. Calculations will come from other components that I'm going to touch upon right now, but we'll be able to use it as an input. So let me show you an example of that. I'm going to do an example of that right now. But let me keep going with this video. Now, we have learned how to do basic simple addition of two values, and we have the value of A and B that we have added together. So what if we wanted to take A and B and also subtract them, multiply them, divide them, and elevate one to the power of the other one? We saw that we have all those components here, right? So we have, for example, subtraction that I can drag and drop here. We have multiplication that I can drag and drop here. and we have division that I can drag and drop here, and I can start plugging in. I can change the size of this panel a little bit, and I can start plugging in here this one and this one to see the results, and this one. Okay, and maybe we want to elevate one to the other. Power. So we want to use power. That's all we like in this is going to, in this course. We want like a lot of power, right? So we have the two values here, and as I said before, we want these two values. We want to subtract them, multiply them, divide them, and elevate one to the other. Okay, so your initial instinct might be, oh, okay. So if I have these two values, maybe I can just copy paste this here for each one of these operations, right? And then start linking them together so that I have the multiplication, the division, and you can see how these panels start updating with the correct information. And this might be okay depending on what you're trying to do. However, if my premise was I want these two numbers and I want to calculate the result of all these operations for these two numbers, then this way of working may not be the best one. I'm actually going to turn off the profiler for now. This might not be the best way, because what happens now is that if I change one value here, for example, only the addition component is updating. So if I wanted to see now these two values subtracted, I need to go here and make sure that I drag into the exact point, or if I can't really nail the exact point, I can double click on the slider and then just write the component, the number 6.32, and then I will have to go here 6.32 and 6.32 and 6.32, and obviously now I have the two same values, multiply, divided, blah, blah, blah. But as you can see, this is a little too tedious and time consuming, and it could get much worse if we have much more operations. So one of the beautiful things about Grasshopper and visual programming with this paradigm of boxes and wires is that I can work with the parameters and keep them all much tighter if I understand that the output of one component can actually feed multiple other inputs. So what I mean with that is that if I want to calculate for these two values all these operations, then what I should do is, instead of replicating the sliders, I can actually take this output and plug it into many, many different inputs, however many I want. There's no limit for that. And then I can take this other output, the value of b, and plug it into each one of these inputs one at a time. If I do this, now the two same values coming from the two same sliders have been linked to a bunch of other components down the road, you see? And now when I change one of them, all the values on all the children components, these ones here, and then as a consequence, all the panels, all of these are going to update synchronously. They're going to update because of the same change that I am applying to this slider. So if what I wanted was for the same two numbers to calculate all this arithmetic, then this is a much better choice. It's a much better approach because everything is much tighter and all these operations are controlled by the same two sliders, the same two values. All right? So depending on what you're doing and where you want to go, probably this is a much better approach than the one that we almost did. Okay? Okay. And okay. going to do now? I'm going to do, what are other data types it can add? It can add vectors, it can add points together, it can add complex numbers, which are a different type in Grasshopper. It can add a bunch of things. Pixel car. Okay, so what I'm going to do now is I'm going to show how to do arithmetic also, but I'm going to use the example of calculating the length of a circle and the area of a circle, for example. Yeah. Let me show you another example of arithmetic operations that we can do with Grasshopper. So for example, that we can do parametrically. So for example, let's say we had the radius of a circle. I'm not talking about the circle as a geometry object. I'm talking about a circle with a particular radius. And we wanted to be the ones who manually calculate what the length of that radius is, what the length of that circle is, and what the area of that circle is. You're probably familiar with the formula of the length of a circle is 2 times pi times the radius of the circle. And you're probably also familiar with the formula of the area of a circle is, it's pi times radius squared. Okay, so we can do that here. We can calculate those two values arithmetically without actually having to create a circle object. So I'm going to scroll down a little bit, and then I'm going to add here a new slider. I'm going to customize its range to go from 1 to 5, for example, from 0 to 5. This one I probably don't want a negative value because I don't want negative radius, right? And I'm going to call this here radius. So for the length of that circle, if you remember, is 2 times pi times the radius. So probably what we need to do is we need to multiply this radius times pi. But how can we figure out the value of pi? You might be inclined to say, well, maybe I just drop a component here and I say this is going to be drop 3.1259, etc., etc. And then this is what I plug in here, and I call this pi. This could be a way to go, but I don't think this is a great idea, just because it's very common in Grasshopper to use sliders as parameters that the user or the designer can customize and they can play with. And it just turns out that for this equation to work, for this formula to work, this has to be the value of pi and no other value. So if somebody sees this slider, doesn't understand what it's doing, and goes into the temptation of changing it, then it's really, really going to mess up with the logic of the process that we're doing, because this will not be the correct length of that circle anymore. Okay, so that's why I don't like using sliders for values that are not supposed to change. I don't think it's a good practice. So I'm going to show you two techniques to do that. One of them is the fact that the value of pi is such a common constant that it actually has its own component. Really, it does have its own component. So here in utilities, it has, you can go in math utilities, you can go here, and this component returns a factor of pi. I'm going to drop a panel here, and I'm going to read this. You can see that here it's giving me the value of pi. So if I multiply 0.5 times pi, I get half pi. Okay, and another thing that's interesting is that this component doesn't give us the number pi. It gives us a factor of pi. And if I look at the input, it tells me what is the factor that I want to multiply pi by. And we can see that in the tooltip it says that it has one locally defined value. It has a default value, which is the value of 1. And that's why pi, this component, is giving us 1 pi by default without plugging anything in. Some components, when you drop them, they have default values that get overwritten if you plug in like something like this here. So if I were to plug in 0.5, this will give us half pi, which then ends up in like whatever mess. This is not great. I just did Control C to undo that change. Okay, so if you remember, the formula of the length of the circle is 2 pi times the radius. So this will come in very handy, because here now we can plug the number 2 to multiply to factor pi by 2 and then end up with the right length of the radius. So you may also, as I said before, you may well, oh, but why can I just write a slider here with the value of 2, and then maybe I can just put here a sign that says, oh, please do not touch this, blah, blah, blah. Maybe, but I still don't think it's a great idea to use sliders to represent values that should not change, for the same reasons that I explained before. So what I find a better way to do that is to, when you want to represent values that should not be changed and should not be touched with, I usually use panels instead to represent that data. Because panels, you can use them to display data if you wire something to the input. But if you double click on the panel, you can actually write inside of the panel. So I can say, hello, parametric camp, and then I can just have that display on the panel, right? But also, I can also just say, I'm going to write here the value of 2, okay? And on top of that, I'm going to right click here, and I'm going to say, I'm going to deactivate multi-line data so that it looks a little closer to this typical structure of how data is represented in Grasshopper. We haven't seen yet what this number means here, what this number means here. We will see that down the road in this course. But for the time being, what's important is that here we have the value of 2 handwritten here. We have 2, we could do a bunch of numbers, we can have a list of numbers, but we're just going to have this one number, the value of 2, that is going to be output here to n, and then this is going to give us 2 pi, which multiplied by 1 unit is going to give us that the length of this circle is going to be 2 times pi. 2 pi times the radius, which is 1. Okay? If this was whatever value, then this would be the length of that circle, right? You could argue, well, but if somebody comes in here and double clicks, they will be able to change the value of the panel. That is true, and there's not really a way to lock this so that nobody can touch it and nobody can modify it. But it just so happens that UI-wise, if you see a slider, you will feel like you want to change it. But if you see a panel, it's kind of saying like, you should probably not mess with this. And also another common trick is that to just move the inputs that you want people to see, very far away from the actual operations. But we will get more into that later on. Okay. So now for the same radius, I will want to calculate the area of that circle, and remember the area is pi times radius squared. So that would be very simple to do. Here in polynomials, you can square numbers, so I can square this number and I can multiply it by a simple factor of pi. So I can double click here and say pi, and then this will be the area of that circle. Radius squared multiplied by pi. And here you go. Simple arithmetic operations with native mathematical components in Grasshopper. Okay. I think we are at a good point now. Our definition is starting to get a bit more complex. So we are at a great point to start talking about how to keep our definitions clean, tidy, and in order. Okay, let's take a look at that. Woohoo! Oh my God, it's so hot in here. What is it already? Is it 3:30? Okay, we're gonna run for another half an hour, and then we're gonna call it a day. Okay. check my phone just a second. Oh, I have a notification that Parametric Camp is streaming. Okay. All right. How's everybody doing? Is it warm, whatever you guys are? It's super, super warm here in Cambridge today. Okay. Yoo-hoo. Where was I? Yes, so I'm going to save this basic arithmetic. Oh, okay. Okay, I'm gonna move all of this all the way here. Okay. Oof, oof. Oy. Okay. I am a little distracted right now. I'm gonna take a 1 minute break. I'm gonna go drink some water. I'll be right back. Give me a second. I'm back. How's everybody doing? Oi. Okay. Oi. Oi. Okay. All right. Okay, let's go a little bit. Let's do this. What is that? Albert. All right, sounds good. Okay, shall we get busy? I think we're gonna. I think I'm gonna do like a small video. We're gonna talk about sorting, sorting things, grouping, aligning, making things look a little nicer, and then we're just gonna call it because uh, my throat is a little off today. So yeah. Okay, so keeping your definition tidy and clean. Uh, okay, so we're going to group uh, uh, naming panels or name panels. Okay, so okay. Okay. As you have seen before, our definition, just for doing like a little bit of arithmetic and a couple of formulas, has grown fairly in complexity, and this, and you will see very soon how this can explode and like the grasshopper definitions. A grasshopper definition is the name that it would usually use to refer to a file that has all these components and all these things floating around. Um, it's very common that the complexity of these things grows so large that it becomes like a visual clutter and it's very, very difficult to read. So I would like to show you some techniques on how to keep your definition clean and tidy so that when you get back to it, or that you while you work with it, or especially if you're working with teams of other people, how to keep things clear so that other people can understand the spaghetti that you have made out of these components. So we can see things, we can see here, for example, that we have a bunch of components and like these things are not aligned, blah, 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 and we don't have a clear distinction of what its inputs, what its outputs. So there's a couple of things that we can do to keep everything a bit cleaner. So for example, something that I can do is I can group components by categories or by operation. I don't know. So for example, I can say I'm going to choose all these components here, and I'm going to press with the middle of my mouse to have this pop-up of options show on my canvas. And there's a bunch of things. I can turn the previsualization on and off. I can enable or disable the components. I can go to settings. I can do other things. But this one here is called grouping. And what it does is that it creates this sort of like group around sliders. And I believe that if you just install Rhino, I believe the default color that you will have here is some kind of green, I believe. But I have customized that color. And what this group does is that now, no matter how you move your components, they're always going to remain grouped in that particular, with that particular group. And also I can click on the group and then move it around so that all the components move evenly. So that is actually very handy. But one of the nicest things that I like about groups is that I can, for example, I can right click on the group, go here, and then type a name. So for example, I can say these are going to be the input parameters. So this is what's important for me. This is the values that I want to use to control my definition. And then the rest is just code. It's just operations that the user of this definition should not really care about. I can also do some playful stuff. So I can go, instead of box outline, I can do like a blob. So I can have these things like be blobby blobby right now. or I can do rectangle outline. So I can have them be like up, plop, 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 and then the the um, the description just updates. I can do the same by double clicking. No, I don't think you can do that. Anyway, so I can do that, and so that I can move all the components synchronously. And I can also change the color. So I can say, for example, these are going to be red because they are the input. So it's very important that they are these ones. I'm going to group them. Now, instead of doing the button and the grouping, I just did Control G, which makes grouping much faster. And then I'm going to right click here and say, well, this color of this one is going to be like a light gray, and these are going to be the main operations. Okay, and so these are going to be the main operations, and then here I'm going to group this, and maybe I find another color, like for example, maybe I can do light blue or light purple, maybe I can do light blue or cyan, and then say these are the results. Okay, so now my definition looks a little better. It's easier to read, it's easier to understand what is what. However, I do have a little bit of OCD, and the fact that these boxes are not perfectly aligned and these are like a little bit off from each other, it's kind of killing me. So thankfully we do have some tools that can help us with that. So if I select all of these components, you can see that these small black squares pop up. These are alignment buttons. So what I can do is, if you're familiar with Illustrator, for example, you can align things along the vertical axis, you can distribute them evenly. So something that I can do is I can say, I'm going to distribute these ones, I'm going to distribute them evenly, I'm going to align them to their center of, so I click this vertical arrow here, and now all these components have aligned perfectly in the vertical, along their centers. But I also, this one is a little closer than this one, and this one is farther away. So something that I can also do is I can select them all, and I can click on these parallel bars so that I can say I want to distribute all of these components evenly in the vertical direction. And now you can see that the gap between each component is identical. So my OCD right now is like super, super happy. But what if I want to align these guys also exactly like the ones that I have here? Well, first of all, something that I can do is I can say, well, I can move this, but if you notice, if I move it at some point, if I move it up, at some point it's going to snap to the same horizontal. Oh, sorry, Control C. If I move it up, you see that it's going to snap. Pop, you see how it just snapped, and now it's perfectly horizontal according to this one. If I do that with that one, and I do the same with this one, poof, it just snapped. Now I can choose them all. I can align them through their center, and then I can also distribute them evenly. And now, oh my God, how much nicer is this, right? I don't know about you guys, but I'm going to sleep much happier tonight with everything clean and tidy and aligned. Oh my God, this makes me so happy. So as you can imagine, reading these kind of definitions makes life much, much easier and much nicer for everybody who's working with Grasshopper definitions, especially because this can grow in complexity very, very fast. Additionally, something that we can do, and it's even a little bit better, is that just as we can name inputs, value A and value B, we can also name panels. So we can right click on this panel and say this is going to be the result of an addition. Okay, this is going to be the result of a subtraction. This is going to be the result of a multiplication. Oh, but you can see that this is, okay, this is, I need to expand this a little bit more. This is going to be the result of a division. And this is going to be the result of power. And now I can do the same. I can snap it, and I can align them vertically and distribute them evenly. Okay, and boop, boop. And And now I think things are a little clearer to read than they were before. Similarly with this, I can do something similar. I can just say, okay, this is going to be the input parameters. I'm going to align this. I'm going to align this here. And this is going to be, for example, this is going to be the circle length. And this is going to be, I'm going to group it, Control G, and this is going to be the circle area. Okay, and this makes things much easier to move around, and I can give them, I can give these things color, of course. Oops, no, not that. Yeah. So I can give these things color, like here, for example. You see, or like this one. Up to you. Okay, so this is keeping definitions tidy and clean. I very, very, very strongly recommend that you do a lot of this, that you group things, that you give them colors, especially that you give them input, that you give them names, and that you keep things tidy and clean. Not just because it's good practice in general, but especially because it's very, very common to grow in complexity and things get very hard to read very fast. On top of that, is really good practice if you're working with teams of people. So if other people have to read your Grasshopper definition, they will very, very strong. They will be super grateful about this. But last, and probably the most important reason, for your own sake, because it's very, very common to write a definition and do something like an amazing algorithm that does something, 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 and then a week after, you will have totally forgotten what you did and why you did things. So using groups as a way of annotating to yourself, adding comments about like, this is doing so much, this is doing so, blah, 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 is actually extremely, extremely helpful if you're going to be going back and forth between files. And because trust me on this one, you will forget how and why you did certain things with this. So if you want to avoid future headaches for yourself in your life, make sure to do clean and tidy code like I just showed you right now. Okay, I'm going to try during the course of this course to add some groupings and some namings as we do more complex stuff. All right. All right. Okay, so this is going to be base arithmetic, and it's going to be grouped. Okay, and all right. I think the next section that I wanted to move on was going to be starting with like basic geometry, so doing like spheres, cylinders, and that kind of stuff. But I'm a little tired, and it's 3:50 already, so we're almost at the 2-hour mark. So I think I'm going to call it a day today. It's also very sunny and nice. I want to go out for a walk or a bike ride or something. So I'm going to leave it here. I hope this was not very painful to watch. But hopefully this is for the best. So that folks can see, so that we can build like a basic intro to Grasshopper playlist, and people can get up to speed very soon with basic Grasshopper, so that we can all move into higher endeavors. I'm gonna do 10 minutes of Q&A and questions and chatting and social. So if you have any comments, suggestions, questions you want to address, please feel free to write them on the chat. We have like 20 seconds lag between me speaking and you seeing that, so I'm going to drink water in the meantime and hydrate. Kartik is asking whether if we can align two groups. I'm not sure we can, because if I do this, you only have either everything goes to one side or everything goes to the other, and if you align them vertically like this, all the components get the vertical alignment, or if we do this, then they get. So I don't know that you can take this group and align it directly with this group as such, but I'm open. I'm always open to learning. So if you guys find a way to do that, I'd be more than happy to take it up and learn from that, and maybe like add a little bit to that video or something. I don't know. Sujai is happy with my OCD. I'm not. Yeah, I hate cluttered Grasshopper definitions. I teach a lot, so I have a lot of students who come, and when they open the Grasshopper file, like I am like, oh my god, and we spend like literally like a good 20 minutes just breaking things down and grouping and naming, because otherwise it's just impossible for somebody who is not familiar with your definition to understand anything from just seeing this web of spaghetti components. It's just really, really hard. So yeah, I'm not sure if you're posting anything on the chat, because I'm having lagging issues, and I don't think my YouTube dashboard is updating. I still can't see who's connected or how many people are connected. Oh yes. So I just refreshed, and yes. Meta Hopper has some amazing organizational tools, Rafael is suggesting. I believe so. Meta Hopper, for those of you who don't know, it's a plugin by Andrew Human. And it does like, I think it was developed while he was working at Case. And it was all about optimizing and redesigning the workflows, the Grasshopper workflows that they were using in the company. So it's a lot of components that help you work with the components and align them and rename them and do like massive operations that would be very manual to do on the UI. I have it installed. I've done some basics, but I'm not really good at it. I haven't really gone in depth at it, but it would be awesome to have. I think Andrew has talked about Meta Hopper in his YouTube stream, so I really suggest you check it out. It's a really good stream. We were actually texting the other day, like oh, maybe we should just like jump on an Instagram live and like have a drink together and talk about parametric design and that kind of stuff. So that may happen at some point, sometime soon. So yeah. Manoshraj Periyasami, I think we have a plugin called Snapping Gecko for aligning. Maybe the me groups too. I have no idea. I don't know about that plugin, but maybe it does. So maybe somebody could take a look at that. Joseph, is it possible to export the flowchart visual code without the background? Oh, it's totally possible. So let me show you. It's super easy. So let's say you have here the definition. When you say the flowchart visual code, we use the word definition to refer to all the components and all the wires and everything that is on the screen. That is typically called a Grasshopper definition. So you can save this as a file, but you can also go here and export a high-res image. You can choose the background. So I'm going to choose a background that has no opacity, so it's alpha 0. And then I'm going to say that in my desktop, I want to say like screenshot.png, for example, right? So I'm going to export this, and this, no, wait. So export, let me find desktop, and this is going to be a screenshot. So this is going to be, and then I'm going to export it, and then this menu pops up that is like is crunching some numbers, and then on my desktop, what is this? In my desktop now I have this image here that contains the full definition, and it's a high resolution PNG. You can see it, and it's also constrained to the visible area. It's much larger in this area because I have the bifocals plugin. So let me just remove that and show you how it does. Here, export high resolution. Let's export this again, and crunching some numbers, and then the screenshot is just now this, which is very nice. But the nicest thing is that this is actually a PNG with transparency. So if I were to bring this on a composition like Illustrator, blah, 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 whatever, I could put this PNG on top of other stuff and I could see it through this PNG. It's not a white background. So it's very nice. It's very nice. So maybe I should, let me write myself a note here to talk about that at some point. Where can I talk about that? I'm going to here, export high resolution Grasshopper image. Yes, so I'm gonna write this down. Yes. Okay, thanks for that. Thanks for that, Joseph. Oh, and yes, the terminology discussion. Oh, that's a good one. So, honestly, what is my opinion? My honest opinion. My honest opinion is that I don't really mind that much about terminology, because I think that where we stand these days in 2021 is that thankfully we come from a period of like roughly 10, 12, 13 years where that has taken all these technologies to become more mainstream and more accepted by the general audience. And if you go to architecture school or design school or product design school, most people know what Rhino is. Most people know what Grasshopper is. Some people know how to use it. So, by the way, sorry, Rafael, can you write down, while I start talking, can you write down a list of like which terms do you think are different and which one are the same? And maybe I can make some differences between some terms, or like specify like, oh, I think that this term is referring more to this kind of blah blah blah. But just write something down, like a bunch of terms that you think are misused or like inter-exchange these days. And maybe I can talk a bit more in detail of some of them. But I think these days a lot of people use a lot of terms like computational design, parametric modeling, generative design, algorithmic design, heuristics, optimization, blah blah blah, to refer to the general idea of people using computers for the purpose of design, and sometimes for the specific purpose of creating three-dimensional geometry, but in a way that is not the conventional way that we come from the world of CAD, from the world of computer-aided design, which was having an UI where you start building geometry, but that geometry is static. It's like how we started like early this morning, like just drawing stuff in Rhino. What I mean by using computational techniques is using techniques that use some kind of that leverage the power of computers running code underneath them to create logics and to create processes that are informed by data rather than by just simple UI interaction on a particular software. Now, I think people who are not well versed on the details of all these technologies and all the techniques that are available, they use the terms interchangeably. So I have heard computational design, parametric design, blah blah blah. All this is almost referred to anything. And for example, like Right now, today, is very fancy to use the term generative design to refer to almost anything that has been designed with a computer running code, as opposed to just an interface. Whereas and I think it's just, and I think like the fact that a lot of people are using all these terms is just a little bit of a fad and a little bit of a mediatic thing. People just want to sound fancy, even though they don't really know the nitty gritties of how these things work. If we were to be a bit more specific about different terminologies referring to different techniques that we could use, I would perhaps start making certain differences. Like for example, I chose to name these computational design live streams because I think computational design as a term is a very general bucket. And I think it's a general bucket inside of which anything that means using computers, specifically using processes that run some kind of computational logic or code or algorithms for the purpose of design of any form, that's what I refer to as computational design. And that is a huge bucket inside of which you can throw anything almost. You could even throw standard CAD inside of computational design, even though that's something that I'm not particularly very interested in focusing on. But but there is it's a very general bucket. Now, inside of this general bucket, we could have smaller buckets, such as, for example, such as, for example, the series that I studied today, which specifically I called Parametric Modeling, because I want to make the difference that design can be anything. You can apply computational design to generating like art pieces or projection or interactive dance. But this particular series was about modeling three-dimensional geometry, which is a lot of what we're going to be doing. So that's why I called it modeling. And I used the word parametric because the word parametric is very, very strongly associated these days to this idea of visual programming languages and the idea of using geometry that has been driven by parameters as opposed to user input. That is what the term parametric is right now, is how it's understood, at least in the field of architecture, industrial design, etc., etc. Even though if you go to engineering, parametric basically means anything that has mathematical rules running that are defined by initial parameters. That's it. So parametric modeling is very strongly associated to this idea of using, for example, Grasshopper to generate geometry, and that's why I chose that term. Some people use parametric design to refer to the exact same thing. I think that's okay, but I don't want to use the word design because for me the word design is very holistic. Design is like thinking about anything pretty much, whereas this series, for example, is very specific about 3D geometry. So that's why I thought the word modeling was a bit more appropriate. And people who use parametric design in a more general concept, as in like, oh, I write processing, blah, 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 I'm a parametric designer. In that case, I think you probably want to elevate like, oh, maybe you're not a parametric designer. Maybe you're a computational designer. If you use other tools that are not just the ones that are driven by initial parameters, such as, for example, in Grasshopper. The idea in Grasshopper, well, I'm getting really, I'm getting really deep into this. The idea is that the paradigm that Grasshopper gives us is that we start by a bunch of initial parameters, we crunch a lot of information, and then we end up with some outputs. But it's a very unidirectional flow. It starts from parameters, it ends in outputs. And that's why I think the Grasshopper environment of things, I like the parametric tag, because for me, parametric represents that idea of like, I start with something, I process it, and then I end up somewhere else. Whereas other techniques that are not so unidirectional, but there are more like closed feedback loops where like you start on a particular state of the program, but the program has a life, it's running and it's changing and it's evolving, etc. And you're constantly going back and forth. then that idea of like initial parameters and ending output is not so clear because it depends on the changes that happen through the life of the program. And that's where I don't see parametric fitting well as a word there. So if you're using those techniques, I don't think you should use the word parametric. I think words such as, for example, generative design is a much more appropriate one, because very common when if you're talking about technicalities, generative design is that design, and it's a design where you use computational techniques to maybe start with a Grasshopper definition, but on top of that Grasshopper definition or a Dynamo definition or whatever you want to do, then you have another entity that is like constantly changing those initial parameters, is looking at the outputs, and is trying to verify those outputs against a particular criteria. So when you guys see all those exercises about like all these boxes that are rotating and moving because they want to optimize the best solar exposure or the least heat gain or blah, 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 those are basically Grasshopper definitions or Dynamo definitions that are running underneath a larger framework that is making them run with tons of different parameters, and then is trying to find which one of those combinations of parameters is giving a solution that is optimized for a particular value. That process, that is a process that I find is a better match for the term generative design, because in generative design, you design the logics, you design the process, yet you still use a generative way of working with those initial parameters to find an optimized solution. It's like putting another layer of computation on top of the basic layer, which could be something as simple as a Grasshopper definition, you know? Okay, I'm talking a lot. And that's what I understand as generative. Or when you start, for example, with like an analysis that you keep iterating over and over again. I think the technical term for those operations where you have a hierarchical tree of relationships, parameters and outputs, but then you use cycles of testing and evaluation, and evolving the system based on that. I think the technical term is called heuristics, because heuristic means just trying something a lot of times, basically, right? So when you hear the word heuristics applied to generative design, what that basically means is that somebody is just like trying a Grasshopper definition many, many times with different inputs and reading different outputs. Now, what's interesting is that there are a ton of very different heuristic techniques. So when you're doing generative design, or when you're doing heuristics, such as, for example, optimizing a facade for a particular solar exposure, you can apply very different techniques on how do you try the parametric definition many times to find the optimal solution. One of them, for example, is called brute force. And with brute force, what you basically do is like you try all possible combinations of all the different inputs, all the different parameters together. That one is the most expensive one because you have to go through all the possible options, but it's the one that supposedly may give you the better result, because since you're trying every single possible combination, then probably you will find the one that is more optimal. As simple as that. Now, there are other ways where you can get an optimal solution much faster by doing some tricks. So, for example, this is a technique called simulated annealing. That what basically does is it starts with a random sample of initial parameters. It looks at the ones that are more optimal, and then it does a second round where it also launches like a set of random combinations of parameters, but random combinations of parameters that are much closer to the ones where we found the most optimal values. And therefore, it's kind of like zooming into the areas where we find combinations of parameters that are more optimal. This way you get to optimal solutions much faster and with less results, but you're also not guaranteed to also get the one most optimal one. that's what I find. That's, for example, another way of doing heuristics. And and then I think when people use the term algorithmic design, um, to me, honestly, that is a very, very similar, almost a synonym to computational design. Because computation, uh, as a term, emphasizes perhaps like the machine as a computer, but mostly like how the machine works. And the computer works with algorithms. Computer programs are algorithms, are sets of rules. So I'm not sure, honestly, I'm not sure how different algorithmic design from computational design as a term is. It sounds a little fancier, so maybe you can impress your clients a bit more with that, but I try to be more of a humble person, so I think computational design for me, it's great. I think somebody wrote a PDF a year or two ago where they basically wanted to break down all the terms, computational design, algorithmic design, blah blah blah, and there was like a huge Twitter explosion of like, oh, what are you talking about? You're being like blah blah blah, whatever. Do I have that document? Do I have that document somewhere here? Um, do I have that document? Wait, do I have that document? Uh, do you guys know which document I'm talking about? It was like a PDF, like 6 pages, 8 pages. Somebody wrote like, let's try to really, um, like break down this problem of like all this terminology, and these are our opinions. This is the title. Oh, okay. And who wrote that? Computational Design in Architecture. Who wrote that? Nate. What is it called? What's his name? The Proving Ground. Nate Miller. Nate Miller. Computational Design in Architecture. Okay, let me. I don't know what I have that. Computational Design in Architecture, Terminology, Caetano Lisant, Defining, Parametric, Inés Caetano, Luis Santos, and Antonio Leitao. No, but this is... Wow, this is a good one. But I was actually talking about a different paper. But this is a pretty good one too. Methodology, Computational Design in Architecture. Nate Holland, I think that was the one that I was talking about. Nate Holland, Terminology, Computational Design. I don't know, I forget. But somebody wrote, this is like a serious paper, like a academic paper, but somebody wrote like a white paper. It was just their opinion, and it started like a Twitter. Okay, I forget who this was, but yeah. Okay, let me go back. Oh, there's a lot of stuff. Okay, computer aided design, parametric design, computational design, generative algorithmic design, building information modeling. Okay, BIM is a little different because building information modeling is very specifically refers to a set of standards on how to design digital files that represent architecture. So that one is a little different, And also it's more of like a representation problem. So it's more about like the structure of how do you create three-dimensional geometry and the information that is associated to that three-dimensional geometry. So the problem there is not the process, and everything that I was talking about is more about the process of how you get to a design, whereas BIM, Building Information Modeling, is more about the structure of how do you store and how do you manipulate data. So it's a slightly different topic. So BIM is basically what's at the core of software like Revit. And as good as Revit is, for example, for production and for managing projects, I don't think it's one of the best tools that are out there for design. So when you want to be, when you're in the designing process, when you are in the thinking stage and you want to try things out, etc., it's more of like when you know what the design looks like and you just want to a very fast and optimized way of producing the construction documents, the budget, the material bill, that kind of stuff. That's where BIM plays a really big role, but not so much on the earlier stages of the design process, I think. So yeah. Generative design is the concept that Autodesk gets as its own term. Actually, I used to work. I used to work at Autodesk, and I used to work at the generative design team. We used to be. I worked very closely with a team that develops Dynamo, and I was working more on the research side. So we did a lot of like experimental prototypes and on how to rethink generative design, and we did a lot of work with robotics, connecting it to our tools. It was a very, very interesting phase of my life, and I have to say I'm very happy that I was there, and I have a lot of respect for my colleagues and for the team that I was working with. So it was a very interesting time. And Rafael, personally, I avoid parametric because people think Zaha and stop taking me seriously. Well, on top of that, yeah, the word parametric um, has been appropriated a little bit by Patrick Schumacher in his theory of parametricism. He has written like a couple of really big books, the Parametricist Manifesto, I think they're called, and he elevates the concept of what you can do with parametric design, but very specifically the forms and the kind of geometry and the kind of visuals that can be enabled with parametric modeling. He elevates that to a style, and he has written these two books that are mostly like almost like theoretical manifestos towards an architecture that is strongly based on this new style that is emerging. This is all according to Patrick Schumacher theory, right? Patrick Schumacher, who is the director of Zaha Hadid Architects right now. I am not sure I agree or disagree with that. I think there is some stylistic component to how parametric modeling has been designed, has been used, or perhaps abused in the past few years. Um, so it could be a thing or not. I could understand it as a style. I'm not sure if I agree with Patrick's advocacy that it should be the new norm, because he's very advocate about like this is what we should all be doing and this is what the new style looks like, and like forget Euclidean geometry, the new line is the Nernst curves and blah blah blah. So I don't think I agree necessarily that that is how things should be in such a strong way as Patrick argues. But I definitely think that his theories when it comes to architectural style are very interesting, and he's also a really interesting speaker. Very controversial, very often. So if you have the chance to see him at a lecture, you may end up uh, being annoyed at his at his rhetoric and his conversation, but it's definitely going to be an entertaining conference. And he's a really good speaker. So he's a really good how does it call when you have like a verbal disputes with people? Not an argument, like like in high school, like you do the debate. He's a really good debater. Exactly. Like debate competition, debate group. So I really recommend that you guys check him out if you have the chance on a conference. Okay. All right, same interesting VB scripting. Oh wow, there's a lot of stuff. How's Visual Basic scripting? It's very similar to C#. It has a very different syntax though, and I don't think it's okay. You can do that here in Grasshopper as well, but I don't think it's getting a lot of traction in the real world, so I don't really like it because I think it's slowly dying, honestly. But that's a very personal opinion. WatchTech is asking. I have buzzwords. Whether possible, describing what the actual design process is to persuade client investors. Consequently, people with computational skill are utilized as selling mean, but when the actual design starts, we're back to all good drafting. Rhetorics. Well, I hear you, WatchTech. And yeah, maybe there is some truth to that. Also, companies need to sell because that's what they do and that's how they pay salaries to their employees. So I honestly can't blame them too much for that. And use fancy words to try sell stuff. Well, I mean, I don't know. Am I guilty of using the term computational design to advertise these live streams? Is it that good or bad? I don't know. Yep. But it is true that there is a slight component of deception if you sell algorithmic design and computational design, but you end up all your processes internally are just like old school CAD. You know, that's not very honest or great. But yeah. How's Andre? Okay, this is gonna be the last question. Probably I want to go. Can you talk about material process and systems group and how computational design relates to physical material research? So I think Andre is bringing that up because at the design school at Harvard, I belong to the material processes and groups system. It's a research group where we do a lot of research at the intersection of physical and digital. So we use a lot of digital fabrication tools and advanced materials and computational techniques to figure out what new conversations can we bring in to the world of making physical artifacts in the world of design. Obviously, my colleagues in the groups are the ones that are a bit more expert on the material process side. I am perhaps the one that is leading or has a stronger emphasis on the digital and computational process, especially with robotics. I've worked a lot with robotics and I've written a lot of robotic code and robotic plugins. And I think it's very interesting because that intersection of material and digital, no matter how much of a computational guru you might be, materials are materials, and even today they're still very hard to simulate and predict. So designing processes that actually take into account the material and try to make it behave according to a particular design, or designing fabrication processes that try to adapt to how materials want to behave, is actually a very interesting back and forth conversation that relates to the real world. And I have a very fun time working in these projects because, first of all, it takes me out of the computer, which is very great. It's great to do every so often, but at the same time, it poses a challenge to me as a designer because it forces me to work with a material that I cannot predict or fully control and that I have to work around with. So, and that becomes a really interesting challenge and one that we learn a lot from. We did a project recently. It got published at Acadia conference where we 3D printed this special lattice. So it was like a really large cocoon made out of special spatial beads of clay where air could go through. So the students that I was working with designed like a really interesting workflow to create these curls that we could 3D print in space. But because all the material was fresh and sagging, we also implemented this like live scanning system where after printing one layer, we could 3D scan it. We could see how much it had deformed and how different the real geometry was from the digital one. And then we could readapt both. We could readapt the digital model to incorporate the changes that had happened in the physical, and then redesign the next layer to recalibrate and to counterbalance that deformation that had happened in the physical world. So that was like a really interesting project that we did, and we do a lot of that kind of research. Are we going to do fabrication techniques on this course? Maybe. It's kind of difficult because already just doing purely digital requires a lot of infrastructure, so I don't know how I would connect to a physical machine and connect the webcam and blah blah blah, but maybe at some point we can do that. Also, in terms of the maps, let me share a link if you guys want to learn more about what we do at the research group. I'm gonna paste the link here, and this is the research group that I work with. And we actually, my colleagues just recently finished the design of a COVID isolation hood, like this like super fast and super cheap deployable hood that doctors can put on top of a patient that is suffering from COVID and is like and they need to work with. And this hood basically protects the nurse and the doctor that is manipulating and helping the patient, and it protects from all the viruses and from all. It's a really interesting, and we made it open source, so it's openly available for download and for fabrication. So that's very nice, and this is the project I was just talking about right now. And this is a class that we taught. I co-taught with Martin Bechholt 2 years ago on material systems and making things with robots and clay. You can also check it out. I think it was an interesting one. A pavilion we built last February in Savisama in Valencia. I don't know. There's a lot of work that you can check here. It's quite interesting, I think. All right, and I think with that, I'm going to call it a day. It's boiling hot here. My microphones are dying, so I'm going to thank everybody here for being this afternoon with me. And thank you very much, everybody. And I will see you next week. Please subscribe to the channel. Please turn on notifications to know when we're streaming again. It will happen on Saturday. And I'm not sure yet if next Saturday we will do also like a full day of intro to parametric modeling, or if we will do half and half. If I will do like an exercise in the morning, like a challenge or a geometric gem, and then just keep recording intro to parametric modeling in the afternoon. I don't know. I will announce that. Whenever I make a decision, I will announce that on Instagram or social media or whatever. But remember, next week, all the streams are going to be here in the Parametric Camp channel. Okay? Wonderful. Have a great weekend, everyone. Thanks for being here. See you. Bye-bye.